Welcome students. In today's session we are going to see about the steps involved in designing an view layer, and then we will be seeing about software quality assurance testings. So after seeing different kind of testing which is needed for software quality assurance, and finally you will be seeing about user satisfaction testing and usability testing. So these are the contents we are going to see in today's session. First is we are going to see about user interface. User interface in the sense, after analyzing the project, we have to design the user interfaces so that we will be able to know how the objects are presented in an user point of view. Here you will be having many objects for our software. So by designing the user interface layer, view layer, you can able to say how these objects are presented to the user from the user end point of view. And then user interface should have the responsibility of displaying and obtaining the needed information in an accessible and efficient manner. It has to obtain the information which is needed by our system in an efficient and accessible manner. So these two are the properties of an user interface. Next is designing view layer. So basically view layer has two responsibilities. One is it has to take the input from the user when it is interacting with the system. When the user is interacting with the system, the view layer has to get the input from the user. For example, if a user is clicking on a button or if he is selecting a menu, so for those actions, my user interface or the view layer has to respond and it has to translate those interactions to our system. The next responsibility is output. In the sense, this layer must paint the best picture possible for the business object of the user. In the sense, it has to display the output. What is the required output which is needed by the user? It has to display the output of the interaction what the user made to the system. So these two are the responsibilities of a view layer. And to design a view layer, so to design a view layer in an efficient manner, you have 4 steps. First step is you have to design the macro level user interface design process. First is you have to design the macro level things. That is, you have to identify the objects in the view layer. So here we have to identify the classes. So those classes should interact with the human actors. Analyze these classes can be analyzed by using the use cases. So first we have to identify the classes and the objects which is inside the classes. So the first step is identifying the view layer object. The next step is micro level user interface design layer. So here in the second step you will be designing the view layer object by applying the axioms and corollaries. So in the first step you will be identifying the view layer object. So whatever objects you have identified in the first steps, it will be designed by using the axioms and corollaries in the next step like micro level UI design activities. So here by designing the view layer object, you can able to say the most usable or you can able to provide the most usable user interaction. Another thing what you have in micro level UI design activities is you have to create the prototype of some of the basic aspects of the design. So prototype in the sense a model. You have to create a dummy model of some of the basic concepts in our view layer design. So this is the second step. The third step is testing usability and user satisfaction. After completing the designing of view layer objects, you have to test those objects by applying the usability testing and user satisfaction testing. By testing the view layer objects with these two types of testing, you can able to confirm that my system is making sure it meets the audience requirements. The fourth step is we have to refine and iterate the design. So from the starting to third step, you have to again and again repeat the steps so that a good view layer objects are designed, a good user interface is developed. Next we are going to see about software quality assurance. To make or to deliver a system in a confident manner, you should follow the testing pattern and you should make sure that your software is working for all the values. So we have to perform the debugging process. Debugging process in the sense, it is the process of finding out where something went wrong in our system. So by finding out the place of taking place error, you can correct those codes so that we can eliminate errors and bugs in the system. For example, if an incorrect result is produced at the end of some computation, you can able to find out the error such that we may sometimes forget to assign the values to the variable, so that may lead to some incorrect results. So by finding out the place of error, you can able to correct those errors. You have some 3 types of errors. One is language error or syntax error, next one is runtime error, the third one is logic error. Syntax error in the sense, if something has been typed incorrectly, like keyword or some necessary punctuation marks, if those has been typed incorrectly, so typing is done incorrectly in the sense, that can lead to syntax errors. So it is easy to detect this type of syntax errors, or this type of errors is very easy to detect. So the next error is runtime error. Runtime error are detected when the program is running. That is, when a statement attempts to do an operation, but it is impossible to carry out this operation. So those kinds of errors are called as runtime error. For example, if the program tries to access an object which is not existing, this may lead to an runtime error. Next is logical error. So logical error in the sense, when the code does not perform the way what we needed. So we need some output, expected output, but the code is giving you some output which is not expected. So in that case, you are having logical error. There is some error in your logic. Only by testing the code and analyzing the result, we can verify that the code performs, whether the code performs as intended or not. So logical errors can also produce sometimes runtime error. These logical errors are very difficult to identify. Quality assurance testing. Quality assurance testing can be done in 2 ways, error-based testing or by scenario-based testing. If you are making your quality assurance testing by providing error-based testing, you have some way of testing. If you are following scenario-based testing, you have some way of testing. Error-based testing. So this is a testing where you will be searching a class method for some particular class of interest. So for some particular class of interest, for particular values, you will be checking whether that program is working correct or not. So this is called as error-based testing. So for example, if you want to test the payroll computation method of the employee, this method is like compute payroll method. So if you want to check this method, whether this method is working correctly or not, so you have to give different values for the parameter hours which is taken by this method compute payroll. So for this hours method, you can give the values like 0, 40, 100, minus 10. You can give a 0 value, you can give a positive value, you can give a negative value, and you can check for all these 3 different values how my compute payroll is working. So you can test your compute payroll method by giving different values. So this type of testing is called as error-based testing, or it is sometimes called as testing boundary conditions. So you are checking the boundary values or boundary limits for this variable hours. Next is scenario-based testing. So quality assurance testing can also be done with the help of scenario-based testing. Scenario-based testing is also called as usage-based testing. So here in the scenario-based testing, you will be concentrating on what the user does, but you will not be concentrating on what product does. You will be concentrating on what user does. You will not be concentrating on what the product is going to do. So here, by using the scenario-based testing, you can identify the interaction bugs. That is, when 2 objects are communicating with each other, whether in the communication you are having any error or not. So those interaction bugs can be identified. Next, it is more complex when compared to error-based testing. Scenario-based testing is very complex, and also it is very realistic when compared to error-based testing. This scenario-based testing will exercise, that means it will be acting on multiple subsystem when we are performing a single test. When we are performing a single scenario-based testing, it will be acting on different multiple subsystem at a time. So this is one real-time or an important based scenario of scenario-based testing. Now we are going to see about the impact of object orientation on testing, and also we are going to see about impact of inheritance in testing. See, the main objective or the impact of object orientation can be summarized by these 3 types of things. One is, some errors are less plausible. Plausible in the sense, they are not that worthy to get tested. Not worthy. Plausible, less plausible in the sense not worthy. Some errors can be more plausible in the sense they are more worthy to be tested. Some errors are new. So, based on the error what you are getting, you can say whether the object orientation will impact the testing or not. So, if it is less plausible, your object orientation will not impact more. If it is more plausible, if the error is more plausible, the object orientation will impact more. Okay, so based on the error what you are getting, type of error what you are getting, you may say the impact of object orientation on the testing. Next is, for example, let us consider you are calling the method compute payroll and you are assigning the value returned by this compute payroll method to a variable x. So when we invoke this method, we cannot say whether this method belongs to a single class or this method belongs to many classes. So this method can also be defined in base class. The same method can also be redefined in derived class. So you cannot say the compute payroll will have only single existence or a single definition for this compute payroll. It can have two types of definitions in base class as well as in derived class. So you have to keep those things in mind. Next is, we have to think about the multiple inheritance. When multiple inheritance comes into existence, it becomes complicated to make the testing. So, object-oriented concepts like multiple inheritance makes the testing more complicated. But we can reduce this complication by designing the axioms and corollaries in an efficient manner. So, by using the axioms and corollaries in an efficient manner, by applying these design axioms and corollaries of the object-oriented design, you can limit the differences between the base class and derived classes objects. Next, we are going to see about impact of inheritance in testing. Consider we are having a situation where we have two classes, one is base class and derived class. Derived class will be accessing the properties and methods of the base class. So you all know what is inheritance. In the base class, you have two methods, one is inherited, another one is redefined. And then in the derived class, you have made another definition for this redefined class. So redefined class alone is defined in a different way or coded in a different way in the derived class. So now we have to test this derived class redefined method in a fresh manner because it is again coded or it is different from the parent class redefined method. So you have to test it. It is worth. Okay. So next, whether we have to test the inherited method of derived class, because the inherited method of derived class is same as that of base class. It is not again redefined. It depends on whether we have to test this method or not is defined or is depends on whether the inherited method is changed or not. Again, base class inherited method has to be tested because this is the primary method and this is not changed in the derived class method. So as this is the primary method, as this method is completely used, as the method and its definition is completely used in the derived class method, you have to test this inherited method. So we are having these complications in our testing when we have inheritance in our programming. So we have to follow the object-oriented design guidelines strictly and we have to test the objects incrementally. So when we do these two things, we can reduce the effect of inheritance in testing. Next, we are going to see about developing test plans. Test plans are used to find the bugs and remove them. Here, we have to develop the test plan. Test plan is developed to detect and identify the problems in our system before delivering the software to the user. So, before delivering the product to the user, test plan has to be developed to identify the errors and bugs or the problems what we have in the system. It provides the roadmap for testing activities. The testing activity can be usability testing or user satisfaction testing or any quality assurance testing. You can do any type of testing activities. To perform these testing activities, the test plan provides the roadmap. Next is, we are going to see about the steps needed to create a test plan. First, we have to create the objectives of our testing. So first we have to create the objectives and we have to describe how we are going to achieve these objectives. And the next is we are going to develop a test cases. So we have to, after describing the objectives of our testing, we have to say what is the test data, what is the input we are going to apply for our testing, what output is expected, what behavior is expected. So all these things you have to explain in the test case. So the second step is to develop a test case. The third step is to test analysis. In the sense, here in this test you are going to test the expected output. So after testing the expected output, you are going to document this output. So what happened? So you are going to document all the things. So that is the third step called test analysis. Then you have three types of testing: regression testing, beta testing and alpha testing. Regression testing, in the sense, this testing is used to discover the errors which is introduced during the debugging process. So this test can be applied when all the tests are passed by some program. So when a program passes all other testing, you can go for regression testing. Beta testing and alpha testing are contrast to each other. In alpha testing, you will be using the users like programmers, software engineers and the internal users. So you will be using these users and you will be testing your software. So if you are using the internal user to test the software, then that test is called as alpha testing. If you are using a selected group of people who are going to use the system but they are not the internal user, then those are called as beta testing. So if you are going to use beta testing, then it has to be included in the test plan. Next we are going to see about guidelines for developing the test plans. So we may have many requirements. So these requirements will be saying the specific appearance or the specific format what we have applied for test plan. So sometimes we may have some format for developing the test plans. So we may have some requirements for developing the test plans. So those requirements has to be illustrated. So that is the first guideline. Second guideline is each test case should contain a schedule. It should contain the list of or the way the work has to be take place, where the test has to be taken place. It has to maintain a schedule and it has to maintain a list of required resources which is needed to perform the test. So these two are the things which has to be maintained by the test plans. The next guideline is, first, to make a testing we have to decide what type of testing we are going to do, whether we are going to do a black box testing or we are going to do a white box testing or we are going to do a top down testing or we are going to do a bottom up testing. We have to decide what type of testing we are going to do. Why black box testing, in the sense, so this testing is like you will be testing whether the output is coming for a given input. So if the input is 1, if the expected output is 0, whether we are getting this output for this input. So that alone, if we are testing, then that is called as black box testing. Here in black box testing, we will not be knowing about the internal working or internal execution of this output. So you will be giving the input and you will be testing whether the expected output is got or not. White box testing, in the sense, here you will be checking the internal behavior of our system. So if you are giving an input and you are expecting an output, whether the output is got by an expected behavior of the system. So here you will be checking the expected behavior or internal behavior of our system. Next is top down approach or bottom up approach. In top down approach, you will be having a common problem and you will be testing the problem and then you will be subdividing the problem. From the top to bottom you will be checking. Bottom up approach, in the sense, you will be testing the small test cases and then in the bottom up approach you will be testing the classes. So these classes will be grouped together and the top level layer will be tested at the last. So you can have either top down approach or bottom up approach for testing. After determining what type of testing you are going to do, you have to document these testing and you have to say specially what we are going to do with this testing. Configuration control system. So you have configuration control system. The configuration control system is used to track the changes what we have made in the code to obtain an error-free code. So configuration control system has to be maintained when we are doing some testing. Next is we can have an well thought out design. So we should have a well thought out design, that is well thought out design will produce a better code. So always after performing testing, your code should be able to produce some better result. So your designing should come out as well thought out design. Next we are going to see about continuous testing. Always you will be seeing about testing at the end of developing a product. So after completing a product development, as a whole product we will be testing. Next we are going to see about continuous testing. Always testing will take place at end of the product development. So after developing your product, at the end of product developed, you will be testing whether the product is working fine or not. But some money or time can be reduced on testing by continuously testing the product during the development phase. During each phase of development of the product, you can test the product continuously. Next, we are going to see about some 5 steps which is used for successful testing. First step is you have to understand and communicate the business or requirement cases for improved testing. Next is you have to develop an internal infrastructure for supporting this continuous testing. Next you have to look for leaders who will be able to commit and work to the own process. Next you will be able to measure and document what you have done in the continuous testing, and you have to document those findings what you have found in the defect recording system. And then the last step is to publicize your improvements so that people will know what you have done better than other people. Thank you students. In today's session we have seen about the guidelines what we have needed for developing the view layer objects, and then we have seen about software quality assurance. We have seen what is a debugging and some type of errors like logical errors, syntax errors and runtime errors. After seeing all those things, we have seen error based testing and scenario based testing, and then we have seen the impact of object orientation in testing, and also we have seen about the impact of inheritance in testing. So after seeing all these things, we have seen the guidelines for developing the test cases, why we need the test cases, all these things we have seen. At last we have seen about continuous testing. So these things has been covered in today's session. Thank you.